Good morning. I am Varalakshmi, Professor, Department of Civil Engineering from Murray Lakshman Reddy Institute of Technology and Management. In this lecture, I am going to give an introduction of gravity dams, which is covered in Unit 2 of Irrigation and Hydraulic Structures. The main syllabus covered in this unit are forces acting on a gravity dam, causes of failure of a gravity dam, elementary profile and practical profile of gravity dam, limiting height of low gravity dam, factor of safety, stability analysis, foundation for gravity dam, drainage and inspection galleries. First, we will start with introduction. That means what is the gravity dam? We know that a dam is a hydraulic structure constructed across a river to form the reservoir. Okay, but what is the gravity dam? If a dam is constructed, dam is nothing but a retaining wall. So, if we constructed a dam, it should be stable. When it should be stable? If it resists the external forces. What are the external forces in the dam? Water pressure, wave pressure, silt pressure, earthquake pressure, like that. So, all these are the forces acting on the dam. So, the dam should resist all these forces. In gravity dam, the dam weight itself resists all these forces. That's why it is called the gravity dam. This type of structure is most durable, solid and required little maintenance. It is a very strong structure. But initial cost is high, but later the maintenance cost is low. The dam is constructed with masonry or concrete. They can be constructed on any dam site where a natural foundation enough to bear the weight of the dam. The most suitable sites for the gravity dams are hard rock areas with less lineaments, that means with less cracks, fissures, folds, faults. Very strong basement is required. So, we must prefer igneous and metamorphic rocks for construction of these gravity dams. Before going to the dams details, what is the structure of the dam? So, this part represents, this line represents the dam. So, dam shape is like that. The dam backside is called the upstream face and the dam front side is called the downstream face. In upstream face, a reservoir is formed. The highest full level of the reservoir is called the full reservoir level, FRL. Okay? In any hydraulic structure, we must provide some free space to generate waves freely. To generate and propagation of waves freely, we must leave some space freely. So, that space is called the free bird. Next, the part that contact with the ground in the upstream side is called the heel. So, these are the very free bird, heel, FRL is the upstream side. Next, when coming to the downstream side, when the downstream contact with the ground, that part is called the toe. And the water is released through spillways. Heel and toe are the very important parts in the design of gravity dam, because the stability of the dam is calculated at heel and toe. The major parts constructed within the dam are galleries and under sluices and spillways. Galleries are constructed at the level of foundation. These are like rooms or tunnels, so tunnels cavities. Because galleries are used to inspect the dam. Because if we want to check the dam stability or observe the any cracks is there in the dam, so for regular inspection activities, galleries are utilized. Under sluices are the structures provided for silting. So they are provided for to reduce the siltings. Spillways are the structures constructed to release the excess water into the downstream. These are the important structures constructed within the dam. The highest part is called the crust. On the crust, a top of it is constructed. In the designing part, we must concentrate on four things. First one, we must design we must calculate the stability of dam in two conditions, major conditions two. That is, we must design in full reservoir condition and empty reservoir condition. Why we should concentrate on these two? If full reservoir water is in the reservoir water is full, then the dam is stable due to the hydrostatic pressure. So here in the full reservoir condition, the major acting force is the water pressure or hydrostatic pressure. Due to that water pressure, the dam is stable. But the dam is not always in full condition. So next, worst condition, reservoir empty condition. In reservoir empty condition, what is the major force here is no water. So water pressure is very less. If no water, there is no matter of waves and silts. So all these pressures are minimum. So what is the highest pressure? Dam weight itself is the highest pressure. So in reservoir empty condition, the dam weight itself plays a major role in stability of the dam. That's why in designing or in the calculation of stability of dams, we must calculate the stability in two conditions, that is full reservoir condition and empty reservoir condition. Next, where the forces we calculate. In both cases, in full reservoir condition and empty conditions, we must calculate the forces at heel and toe. The forces between heel and toe should be equal. So that's why in designing of gravity dams, we must concentrate on full reservoir and empty conditions, and the forces in two cases at heel and toe. That calculations are very, very important. Next, heel, contact with the ground on the upstream side. Toe, contact on the downstream side. Abatement, sides of the valley on which the structure of the dam rests. Galleries, small rooms like structures left within the dam for checking operations. Diversion tunnel, tunnels are constructed for diverting water before the construction of dam. This helps in keeping the river bed dry. Spillways, it is the arrangement near the top to release the excess water of the reservoir to downstream side. Sluice way, an opening in the dam near the ground level, which is used to clear the silt accumulation in the reservoir side. So now we will go for history and development of the gravity dams. Gravity dams construction is not a new technique, it is the olden techniques, but the materials, construction methods and construction styles are changed time to time. So we must know what is the history of gravity dams. Gravity dams were the first type of dam constructed and were made from stone bricks. It was built by the Egyptians around 2950 to 2750 BC. The dam is called Sedel Kafra and meaning of the dam is Dam of Pagans. A covering of limestone was applied to the dam to protect it from erosion. Due to shoddy and hasty workmanship, the dam failed to be watertight, eventually resulting in its erosion after only few years. So, the first dam is constructed by Egyptians, but the dam is failed within few years because of due to the non-skilled labors. The initial dam is constructed with stone bricks, stones and stone bricks with the combination of limestone. Another dam was supposedly fabricated around 3000 BC in the town of Java located in Jordan. These gravity dams were part of a water supply system. Next dam is constructed in 3000 BC in Java. It is constructed for water supply to the cities. The first dam is constructed for flood controls. The Romans built their gravity dams in the Iberian Peninsula region of North Africa and in the Middle East. A dam located at Homs, Syria in 284 AD impounded one of the largest reservoirs built by the Romans. The dam was 6,562 feet in length and held back about 90 million cubic meters of water. So the Romans constructed a huge reservoir, huge dam in 284 with capacity of 9 million cubic meters of water. Around 100 AD, the Romans became the first civilization to use concrete and mortar in the construction of gravity. So up to that they are using stone bricks, stones with limestone combination. After in 100 AD, they are constructed gravity dam first with concrete and mortar. One example of that type with combination of that gravity dam is Ponte di San Mario. Later gravity dams used a trapezoidal cross section. After 100 AD, the cross section up to 100 AD, the dam is a straight line shape. But after that, the cross section is changed in trapezoidal shape. A trapezoidal shape means the basement width is very high, and when coming to the top of the dam, it is narrow width. That is called the trapezoidal shape. Nowadays, we are using the trapezoidal shape in construction of gravity dams. This cross section eventually evolved into the common triangular cross section design of today's gravity dams. The first version of modern gravity dam was built between 1765 and 1800 in Mexico. First modern dam, present days utilizing dam, is constructed in 1700s in Mexico. After that, they came to know the most advantageous cross section for a gravity dam was triangular with vertical upstream face. So base is width is high and top is narrow. Next. With the development of Portland cement came the development and construction of supergravity dams such as the Hoover Dam that was nearly 60% higher than and 2.5 times the size of any other dam existence. In present also, Hoover Dam is the biggest dam in the world. The amount of water of this storage, the amount of stored water in this dam are 38,550 million cubic meters. That means 46,498 million cubic yards. Today, gravity dams are still being fabricated out of concrete, but with the incorporation of post-tension steel, a new development in their construction. In present days, we are using the concrete Portland cement with the combination of steel. However, the construction of gravity dams in 1960s and building of these massive structures has slowly been tapering off due to the high labor and construction costs involved. So slowly the structure is changed. What are the materials utilized in the construction of gravity dams? Concrete, masonry, sand, silt, timber, etc. are used in the construction of gravity dams. Major are concrete, masonry means stone, concrete bricks, sand, steel, timber, etc. The materials required for its construction must be available locally or short distance from the construction site. We must take care that the materials are available local or surrounding the reservoir site because it decreases the distance and cost of construction. If the material to be transported from far off distance, then hollow concrete dam is better choice. If we are unable, there is no chance of availability of materials near the site, then we must prefer hollow concrete dams. Otherwise, gravity dams. Steel dams are not used for major works. Today, steel dams are used as temporary dams for the construction of permanent dams. Steel dams, timber dams, all these are not the permanent dams. They are constructed as temporary dams before constructing the major dam, because before constructing the reservoir or dam, we must modify the river flow and divert that river. So, for these activities, modification of the river and diverting of the river, we must construct structures, hydraulic structures like dams. For that structures, we are using the steel timber before constructing the permanent structure. Timber dam life is not more than 30 to 40 years and must have regular maintenance because steel dams, timber dams have less span, less time. The design of concrete dams involves consideration of various construction materials during the investigation of phase. So the design of concrete dams involves various investigations. That means durability, stability, like that. And assessment is required on the availability and suitability of the materials needed to manufacture concrete qualities, meeting the structural and durability requirements and of adequate quantities for the volume of concrete in the dam. We must measure the durability of the concrete. Construction materials include fine and coarse aggregates, cementitious materials, water for washing aggregates, mixing, curing of concrete, and chemical admixtures. So, fine, coarse aggregates, mixing, curing, all these are materials should be available. One of the most important factors in determining the quality and economy of the concrete is the selection of suitable sources of aggregates. So we must compulsory define where coarse aggregate is used, where fine aggregate is used, where medium aggregate is used, where curing is needed. So we must take care on that. In the construction of concrete dams, it is important that the source have the capability of producing adequate quantities for the economical production of mass concrete. The use of large aggregates in concrete reduces the cement content. So large aggregates with the concrete reduce the cement content. So we must take care on stability, durability, and cost of the materials. Next, coming to foundations of gravity dam. Compulsory, a gravity dam needs a very strong foundation. That strong foundation is available in igneous and metamorphic rocks. First preference is igneous, after that metamorphic. The foundation site should be free from structural features like folds, faults, joints, or cracks. So compulsory, it is away from folds, faults due for reduction of percolation losses and weak basement. Single type formation is recommended to avoid differential settlements. So if possible, we must prefer single type formations. Earth has the nature of combining others. So many factors, that means combination of sedimentary and igneous, combination of igneous and metamorphic, combination of sedimentary and metamorphic, like this. So we must prefer single formations. The base of the foundation should be stepped so as to increase the shear strength of the dam, because the foundation plays a very important role in the strength of the dam, because at the foundation uplift pressure acts more. In foundation treatment, we preferring the grouting, preparing the surface. First we prepare the surface, next grouting the foundations. In grouting, we are using two techniques: consolidation grouting and curtail grouting. A grouting is not discussed in detail in the irrigation structures, because it is already we should know in the you should know in the geotechnical engineering too. Now we are coming to the forces acting on the gravity dam. Majorly 8 forces acting on the gravity dam. They are water pressure, weight of dam, uplift pressure, pressure due to earthquake, wave pressure, silt pressure, ice pressure, and wind pressure. So all these 8 pressures or forces majorly act on the gravity dam. So first we look at the major forces, because the stability is depend on these forces. The first one is the major force is the water pressure. So water pressure acts back side of the dam, upstream side of the dam, because a reservoir is formed on the upstream side. Similarly, it acts on the downstream side also. So in the design, because water is released to downstream, that's why we must balance the water pressure force at the heel and toe. The water pressure acts in triangle shape. Water pressure acts in triangle shape. Here H represents the height of the water. So the water pressure acts at h/3 height in triangle shape back side of the reservoir, upstream side. And in the downstream side also similarly H represents with H dash. So H dash represents the water pressure. Second one is the dam weight. A, B, C, D, E, F is the dam. It represents the cross section of the dam. So the dam weight acts vertically downwards because weight is due to gravitational force. So dam weight acts vertically downwards. Next one, uplift pressure. Uplift pressure acts below the dam, exactly up to the dam foundation. Uplift pressure acts below the dam site. This is the uplift pressure. It is at the basement of the dam. The uplift force tried to pull the dam above the surface. So uplift pressure acts vertically upwards at the dam. Next one, silt pressure. Silt pressure acts upstream side of the dam only because the reservoir is formed and silt is occurring in the reservoir only. So silt pressure acts upstream side of the reservoir far away from the dam in the triangle shape. So PS represents the silt pressure. Next one, earthquake pressure. Earthquake pressure acts on the reservoir side with a triangle shape with some curve at the top. PE represents the earthquake pressure. Next, wave pressure. Wave pressure also acts in the upstream side of the dam. So waves are generated at the top of the water. So the wave pressure also acts on the top of the water. Wind pressure acts on the top of water due to wind in the upstream side. Ice pressure not common in India. It is common in cold countries. When water freezes, it forms ice. Ice has more weight compared to water. That's why in the design of cold countries, we must take care of ice pressure. So these are the major forces acting on the gravity dam. In next lecture, we must discuss each force clearly. Okay? Thank you.